Yes, hello everyone. I'm Ronuja sir speaking. You are watching Demultiplexer. I have already shown you what is a multiplexer. Now today's topic I am giving demultiplexer. So what is demultiplexer? Demultiplexer is a combinational circuit. Yes, it is a combinational circuit that performs the reverse operation of a multiplexer. Combination circuit, based on the input the output comes, and over here the reverse operation of the multiplexer. So multiplexer, so demultiplexer. What is demultiplexer? Now it has single input, so input is only one. So in the case of a multiplexer, you have many inputs and only one output will be coming, and over here you find that one single input gets in and n selection lines and maximum of 2 to the power n outputs. Okay, and the input will be connected to one of these outputs based on the values of selection lines. So it depends upon the values of the selection lines. So selection over here is very important to. So demultiplexer is also called demux, mux. Okay, now after that what we have is that we go to the next thing, that is 1 into 4 demultiplexer. So 1 into 4 demultiplexer has one input, that is I is the input, two selection lines S1 and S0, and four outputs Y3, Y2, Y1 and Y0. The block diagram of 1 into 4 demultiplexer will be just shown, and before that the single input I will be connected to one of the four outputs. Yes, and Y3 to Y0 based on the values of the selection lines S1 and S0. So you have the input 1 and you have the the S1 and S0, and demultiplexer is formed, and from the output is having Y0, Y1, Y2 and Y3. Now then we come the truth table of 1 into 4 demultiplexer. So the selection lines are there, 0 0 0 1 1 0 1 1, and the outputs are given. You will find that diagonally a 1 1 will come, so because it is coming to the particular, you find the block diagram also, and uh, how you will deduce from the truth table. So from the truth table we can directly write the Boolean function for each outputs as y3, s1, s0 and I. The input line is there, and s1, s0 and I the input line, and y2, and then y1 is there, s1, s0 and I, and y0, s1, s0 and I. So you get these outputs, so we can implement this Boolean function using the inverters and three input AND gates. So just check with the thing, inverters and three inputs. There are three inputs. Okay, and I is the input mainly, and S1 selection line and S0 selection line, and you find that based on this the AND gates are there and the NOT gate over here. So this should be in your mind, the circuit diagram of 1 into 4 demultiplexer. Now we come, you can implement 1 into 8 also demultiplexer, and 1 into 16 demultiplexer by following the same procedure. So in the same way you can do that also. And how you do that? So implementation of higher order demultiplexer, 1 into 8 demultiplexer. So let us implement 1 into 8 demultiplexer. So you are implementing using 1 into 4 demultiplexer and 1 into 2 demultiplexer. Okay, so implementing the higher order. Yes, we know that 1 into 4 demultiplexer has single input. Yes, we know, we have already done, two selection lines and four outputs. Whereas when you are doing 1 into 8 multiplexer has one input, one is there, and three selection lines and 1 into 8, so 8 outputs. Now we require two 1 into 4 demultiplexer in the second stage in order to get the final 8 outputs. Yes, since the number of inputs in selection stage is 2, we require 1 into 2 demultiplexer in the first stage so that the output of first stage will be the input of the second stage. So while I'll show you the diagram, you will be understanding how the particular thing is going on. Output of the first stage will be the input of the second stage. I'll show you. Input of the 1 into 2 demultiplexer will be the overall input of 1 into 8 demultiplexer. So let us see how we are doing that. The truth table of 1 into 8 demultiplexer, so that there will be 8 outputs. You have already seen y0 to y7, and selection lines also, 3 selection lines as I have already told, and the rest is the same, only one is taken. See, on one you will be getting diagonally, one will be you will getting. So this is the pattern what will be followed, and this is as usual. We have the selection lines 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Now we come to the next slide, that is but before that, let the 1 into 8 demultiplexer has one input I, 3 selection lines, it's telling S1, S0 and S2, and outputs Y7 to Y0. So we have already seen that. Now we come to the block diagram of 1 into 8 demultiplexer. So you can see how the output is going as an input of 1 into 4, how the output of the demultiplexer 1 into 2 going to the 1 into 4, and totally forming 1 into 8 demultiplexer. So that the common selection line S1 and S0 are applied to both 1 into 4 demultiplexer. The outputs of the upper, you can find the upper, yes, 1 into 4 demultiplexer. Okay, and you can also see the demultiplexer are y7 to y4, yes, and the outputs of the lower, that is 1 into 4, that is this side, you will find that 1 into 4 demultiplexer y0 to y3, yes, these are the 4 output lines. So totally you got 8 output lines from the 2. Now the other selection lines S2 is applied to 1 into 2 or S2 into 1 into 2 demultiplexer. If S2 is 0, then one of the 4 outputs of the lower 1 into 4 demultiplexer will be equal to input I based on the values of the selection lines S1. Yes. Okay, on this S1. So it is done here. So you can very well understand S1 and S2, both are there. So similarly, if S2 is 1, then one of the 4 outputs of the upper 1 into 4 demultiplexer will be equal to I based on the I means input based on the values of the selection lines S1 and S2 over here. So this is clear from here, and then we go to the last part, that is 1 into 16 demultiplexer. So let us implement 1 into 16 demultiplexer using 1 into 8 demultiplexer and 1 into 2 demultiplexer. We know that 1 into 8 demultiplexer has single input, 3 selection lines and 8 outputs. We already know. Whereas 1 into 16 demultiplexer has single input. So always in the demultiplexer there is a single input, 4 selection lines, because why? And 16 outputs, because 2 to the 4, 2 to the 4, 4 to the 8, 8 to the 16. So 2 to the power 4 you will get. So that's why 4 selection lines and 16 outputs. So we require 2 1 into 8 demultiplexer in the second stage in order to get the final 16 output. Since the number of input in second stage is 2, we require 1 into 2 demultiplexer in the first stage, so that the output of the first stage will be the input of the second stage. Again, I will show you. Okay, input of this 1 into 2 demultiplexer will be the overall input of the 1 into 16 demultiplexer. Same as that we have done in 1 to 8. So over here you see 1 into 2 demultiplexer is there, input I is there, S3 is the selection line, and over here S1, S2 and S0 is there, and you find that is the output of 1 into 2 is going into the input as an input of 1 into 8, and the output of 1 into 2 is going as an input to 1 into 8 demultiplexer for the lower half. So now you see the common selection line S2 and S1. Okay, you can very well find an S0 over here are applied to both the 1 into 8 multiplexer, demultiplexer, and out in the upper, okay, as well as in the lower, you can see. And then the other section line S3 is applied to the 1 into 2. S3 is applied into 1 into 3, 2 demultiplexer. So if S3 is 0, then one of the 8 outputs, yes, one of the 8 outputs of the lower multiplexer will be equal to input of I based on the value of the selection lines S2 and S1 and S0 over here. And similarly, if S3 is 1, so if this S3 is 1, so what will happen? If S3 is 1, then one of the 8 outputs of the upper 1 into 8 demultiplexer will be equal to the input I based on the values of the selected lines S1, S2 and S0. So we find that this is all about the demultiplexer. Thank you. Okay. Thank you everyone for joining. Yes. Thank you.